Excellent. So welcome to the session on Reap the Benefits of Retrieval Augmented Generation, or RAG, the key being without the hassle. And so what's the hassle? Well, we're going to explore what you might perceive that as being and how we can simplify that. So I'm Mark Hornick, a Senior Director of Product Management for Machine Learning and AI. And what we're going to be talking about today is a basic, RAG introduction and challenges, just to sort of ground everyone in what we're talking about. Then I'll give a brief Select AI overview, because that's the key component that we're going to be focusing on today. I'll give a demonstration using a chatbot that we built using the Oracle Apex low-code, no-code development environment. And that's based on using the Select AI capabilities that we're going to talk about later. Could dive into the Select AI for RAG, and then the majority of the time is a demonstration using Select AI via the DBMS Cloud AI package, which will give us SQL and PL SQL access to interact with the LLM and our retrieval augmented generation process. And finally, a few resources for you. So to get started with retrieval augmented generation, why is this such a valuable technology? Well, it actually combines the strengths of retrieval-based AI and generative AI. And as you see, there's a host of benefits that come from leveraging retrieval augmented generation, everything from increased accuracy through transparency, efficiency, and the like. But what is it really doing behind the scenes? Well, there are three key components as indicated in the name. One is retrieval. Let's find the information that's most relevant to the user's prompt. Whatever's being asked, what content can be used to support answering that prompt? So this is information that might be available in private knowledge bases, or more commonly, vector databases. And we'll say a bit more about that in a moment. Once we have this content, chunks of text that we want to use to support that, we augment the user's prompt with this additional content. And that augmented prompt then is sent to the LLM to help it generate a more informed response. That with this retrieved information, we can have more accurate, relevant, and context-aware answers. So what does the process look like for RAG? Well, if you've implemented this yourself, this might look familiar to you. You have data from a variety of sources, and we're going to be focusing on text documents today. You have a document loader that brings that into perhaps a central cloud storage area. And then we do document transformation. The transformation, the key one there is to take individual documents, break them up into chunks, and each one of those chunks, some set of characters, is going to be sent to an embedding model, or what we call a transformer. And this is going to create a vector that we're going to store in a vector database. Now, what's a vector? Well, a vector is an abstract numeric representation of the semantic content in that text chunk. And we're going to do that for every one of the documents that we have in each of the chunks itself. Now, once we've populated our vector database, we're also going to create a vector index. Now, the reason why we need a vector index will become apparent in a moment. To use our vector database to retrieve content, well, we have the user prompt that we're going to convert to a vector so that we have its abstract semantic representation. And then we can compare that vector against each vector in our vector database. Now, as you can imagine, the vector database probably has thousands, millions, perhaps even billions of vectors. And we need a very efficient way to find similar vectors, rather than doing a one-off comparison from the vector that we've created off of the user prompt and all of the content in the vector database. And that's where this notion of a vector index comes in to make that very efficient. The next part is, it's not just to retrieve the individual chunks that are relevant. I mean, that could be useful, and to find the documents that are most relevant. But what we want to do is take those chunks and allow the LLM, the generative AI model, to take in that content, use our prompt, and have a much better response come back that is informed from the content that we trust. And so this is where we're using the vector database for RAG. Now, if we have new content that comes in, well, we need to just repeat this process. We go through this entire sequence and continue to either update the vector database or add new content to the vector database based on the content that is coming in. But what is this in a little bit more concrete steps that we might go through? Well, suppose if we start off with, we're interacting with our LLM, we say, well, what are the benefits of Select AI? And we have a chat history because we also were saying, well, tell me about retrieval augmented generation. So clearly, we're trying to couple these two together. You might say, well, let's bundle up through the transformer. We will then search our vector database to find the vectors that are most relevant. Based on the IDs that we get, well, we'll do a search in our relational database to retrieve the relevant content, the documents that we want to use. And then we're going to augment our prompt and send that augmented prompt to the LLM with the goal, of course, having more accurate responses based on the content that we trust. Now, to implement this, you might have done this already yourself. And one of the things I thought might be interesting just for this presentation was, what if we asked ChatGPT to generate the code for us? Is this something that we might do to avoid having to code it ourselves? Yes, so we have a prompt, generate the Python code that accesses a corpus of documents from Oracle Object Storage. It chunks the documents for generating a vector per chunk using an OpenAI transformer, stores the vector in a separate vector database, and then create an index for faster retrieval. Well, if we start looking at the code, we have Python packages that have to be imported. We have various configuration details. We initialize the client. We set up the quadrant collection. Oh, this ChatGPT decided to use the quadrant vector database. We are fetching files from Oracle Object Storage. We have our chunking logic. We have to generate the embeddings. And then we have the overall pipeline, which is going to iterate over all of those chunks. And finally, we have our vector database, vector index created for us. Okay, that's a bit of code. We have to manage that code. We need to presumably understand it as well. But we're only halfway there because that's just creating the vector index. The next part is to code to use the vector index and perform RAG. So again, let's ask ChatGPT for this. Now use the vector index, which stores corporate policy documents, to implement a RAG workflow to retrieve content that answers the prompt, what is the vacation policy for individual contributors? Yeah, we have a corpus of documents about corporate policy, and we want to make sure that it's grounded in our specific content. Now, say be sure to produce a vector for the user prompt, retrieve relevant chunks of text, create an augmented prompt, and send to the OpenAI LLM and return the response, which is printed out. So again, we have Python configuration, client setup. We need to have a function that embeds, creates a vector embedding for our prompt, retrieve the chunks from the vector database, build the augmented prompt, send that to the LLM, and then use this these set of functions to actually produce the RAG flow. Now, you need to have an environment that will host this code. You'll need a Python engine. You'll need to configure that. You need a VM, presumably, that is running 24/7 to support this. And you have to manage that and update it as appropriate. Don't forget security aspects, that if there are CVEs or other issues, that you need to make sure that any holes are plugged quickly. But that's another issue. So what is it we do with this RAG pipeline example if we're talking about the Oracle context with Oracle Autonomous Database and Oracle Database? Well, we're leveraging AI vector search in the Oracle Database 23AI. And so instead of having two separate components, we have a single component, the Oracle Database with AI vector search. So any synchronization issues that might arise between updating the vector database along with our database data is done atomically within a transaction within the database. But we have the same process. But with Select AI, we're actually going one step further. We're leveraging the AI vector search in the database, but we're also automating this entire process. So we have conversation management, keeping track of the conversations, automatically converting your prompt into vectors for search, and then generating the augmented prompt, sending that to the LLM, and with the goal, of course, getting a more accurate response. Now, how do we make this possible? Well, with Select AI, there are really just a couple of simple and declarative steps. The first one is we create what we call an AI profile. And the AI profile allows us to specify the AI provider. Which LLM do we want to use? Which transformer do we want to use? What is the name of our vector index that we're going to create? The second step is to create that vector index. You're simply going to specify where does the content come from and which profile do we want to use. After these two simple steps, we then can start asking questions. We can do this in two ways. One is at the SQL command line, if we want to do this sort of interactively in a SQL prompt, to say select AI, AI being a keyword, and narrate, followed by our prompt. And we'll see that in the demonstration later. And also the DBMS Cloud AI package has a function called generate, where we can provide the prompt, the AI profile, and use the narrate action as input to say that we would like to have the RAG result produced from our vector index. Now, Select AI. We've been talking about Select AI. You might not be familiar with this tool. Essentially, it's a component that's available with the database that supports LLM-enhanced database application development and productivity through natural language. And what we're showing here in the context of RAG is with Oracle Autonomous Database 23 AI. So what are some of the use cases that Select AI is applicable to? One has to do with natural language to SQL generation or SQL query generation. You might want to ask a natural language question about your database and get the result processed and see the tabular results back. Perhaps you want to assist database developers in writing SQL queries against their application. Not everybody is a SQL expert, and they might know what they want to get out of the database, but how do you write the SQL to actually do that? Well, we can have it run, write SQL queries against your specific schema. Maybe there are SQL queries and you want to understand step by step, what is it doing? So you can validate if that is producing the right result, or just to learn what that query is doing. Another one is still to return structured query results in text to present to users, because not everybody wants to see a table as the result. Maybe you want the LLM to summarize what that content is and give you some prose text. Now, the second area is a basic chatbot interaction. You are quite familiar with this from any of the chatbots that are available from the various AI providers. But for this, you could generate content using the LLM with simple or complex custom prompts. And these can be done easily from your database to reach out to the various AI providers and the LLMs. Perhaps you use this for email generation, generating a prompt yourself that contains details about individual customers that you want to have a tailored email generated. Or maybe you have text that you'd like to get some sentiment analysis. Synthetic data generation. Well, you have new applications that you're developing, and you might not have any test data for that. You could generate it yourself, but you can also use the LLM to do that. And Select AI allows you to generate, quotes, realistic data to populate database tables that can support applications for testing and debugging in some real sense. The last one, of course, which is the topic of today, is retrieval augmented generation, where you can ask questions and get more relevant and accurate responses by using content from your trusted and private documents. So I'm going to switch now to the Ask Oracle chatbot demonstration. Let me just change screens here. All right, so this is an Oracle Apex application that's developed on top of Select AI. And we're just going to do a few operations here to give you a sense of how does it interact with the LLM. Now, the first thing we might ask is we just want a simple chat interaction. And so for this, we have what is Oracle Autonomous Database. You can pop that in. And it will take a little bit of time to have the connection to the LLM established and then generate the response. But what we're doing here is just a simple chat. We're asking the LLM to respond to this using its general knowledge. And there's no specific information from our database that's going to be used for this. So we'll just give that a few seconds to finish off. And we see, yes, Oracle Autonomous Database, a cloud-based database service. And it's going to tell us about the various features that are there: self-driving, self-securing, self-repairing, and several other aspects of autonomous database. But let's say that we want to interact with some tables that we have in our database. And so if I have tables that consist of, customer data and sales data and other information, I might say, how many customers do I have in each country? And so I can ask my database here to produce such a result. Now, this is going to use the AI profile named OCI GenAI, because we're using the Oracle Generative AI services to support the functionality that we're showing here. And this is going against the metadata that we have in the database for our specific tables, and it's going to use that to generate the result. And here we see that we have country name and we have the customer count. Now, one of the other things we might want to do is use our conversation capability to just build on that. So we'll say, let's break that out by gender. So our customers, we want to add some columns to that. Let's see what it actually produces here. And indeed, it does what we ask, but that's not exactly what we would like to see. What we'd really like to see is, can you change that to have the country in one column and other columns such as male, female, and total? So let's see what it does in that case. So you see that we have a conversation, and it's continually building on that and interacting with our database to do natural language to SQL generation. And there we got the result that we were expecting. But let's move on to a RAG use case. So I'm going to create a new conversation. We're going to change our AI profile. Let's go into this and select the one that we're going to be using for AI Camp. So here we have the RAG profile with that. Do this, save, and now we'll come back. Refresh that, and you see that we're using the GenAI RAG AI profile. Now with this, let's say that we want to generate a narrated result. And what we're going to ask is, what are the benefits of Select AI for retrieval augmented generation? So this is using the AI profile that we've predefined. It's using the vector index that we've already set up, and it's just allowing our user, us in this case, to ask questions against that. So this is giving us a description of what Select AI Retrieval Augmented Generation offers, and it's showing us the sources, the documents that are used to support that. Not only the documents, but also the offset within the text to let us know, where specifically in the document that came from. But let's go a little bit further and say, how do I create a vector index in Select AI? That's taking a few seconds to do the processing. And it's going to say that we need to use the create vector index procedure. And it even draws on an example that illustrates how to use that and the specific source. Now, The vector index that we're using is based off of blogs that we have in the blogs.oracle.com/machine learning site. And so we're actually taking text, or we have taken text from these various blogs to populate our vector store and then to create the vector index from that. So that's what we're using in this example. The last one I'll show is, what do I need to specify in my AI profile to enable RAG? And again, it's taking a little time to retrieve the specific documents, the chunks that we want to use to augment the prompt, sending that to the LLM, and having the LLM produce the response. And so here we see the create profile and what we can use to specify some of that information and where that's coming from if you wanted to see the actual document. All right, so that's the demonstration that we are showing for the chatbot. Let's go back and say a little bit more about the specifics of Select AI RAG. So with Select AI, you have the choice to use a wide range of AI providers and LLMs and transformers. So here you see the list of AI providers, whether it's be Oracle's own OCI Generative AI service. There's OpenAI, Azure, Cohere, Google, Anthropic, Hugging Face, Amazon, and also any provider that supports that's OpenAI compatible using the OpenAI API for that. We can also tie into those. And more recently, we have the ability to support private endpoints, because not all users want to use a third-party provider. They don't like the idea of any of their information, whether it be metadata or data or prompts, being sent to a third party. And so in this case, on OCI today, you can spin up your own VM, host your own LLM, and use that as a private endpoint so that you have much greater control over what is being sent to the LLM and who has access to it. Now, to use Select AI, we have a number of actions, we refer to them, on the SQL command line and also through the generate function, which we'll hear a little bit more about. Show SQL allows us to show the generated query that came back from the LLM. And as you see on the GIF on the right, we're also looking at the run SQL results, where we're saying, actually run the query that comes back, or is showing now, show SQL to show us the SQL that was actually generated. We can also use explain SQL to explain the generated SQL query, narrate, which is going to support both NL to SQL and retrieval augmented generation, depending on the AI profile that's used. If you have a vector index specified, it will return a RAG result. And if it does not, it has specific tables that are being accessed, it'll do natural language to SQL. And then there's the chat action, which simply allows us to have the pass-through to the LLM, taking your specific prompt, sending it to the LLM, and returning the result. So Select AI RAG then is simplifying the process, as we've said, and it's allowing basically any database user to leverage this powerful capability without the hassle, because you don't have to write the code, you don't have to maintain the code to create the vector index, to do the entire RAG process. It's all part of your database. So we're able to give the LLM new knowledge without the complexity, the overhead, the cost of having to fine-tune an LLM, right? That's one of the main benefits of retrieval augmented generation. We're doing the semantic similarity search for you and leveraging the in-database AI vector search capability with 23AI to support that. We fully automate the orchestration steps to take advantage of the vector index pipeline. What does this look like in step one? Well, we are leveraging, accessing content from a variety of sources, and these are just a few that are available. The object storage, S3, the Azure Blob Storage, NFS, and GitHub. Autonomous database with Select AI will retrieve the content from there, it will chunk that and send it to the transformer, returning the vectors that are produced from that, and then storing those in the vector store. Now, a couple of interesting points here. One is that the vector store is actually in Oracle Autonomous Database because we're leveraging AI vector search from 23AI. So this is really only one component. Now, you can use a transformer from your favorite AI provider, or you can take transformers that are in ONNX format, where ONNX is the Open Neural Network Exchange format. It doesn't just deal with neural networks, by the way, but we use that format to allow models to be brought into the database and used with the in-database ONNX runtime. So this entire process can be done essentially within your autonomous database. Now, to create the vector index, we first specified the profile. So we have a profile name here of OpenAI GPT. The provider we're going to use in this example is OpenAI. We have the credential that allows us to interact with that provider. The name of the vector index is my vector index that we're going to be leveraging for RAG. The model, GPT-4, and the embedding model also from OpenAI, text embedding Ada 2. We want to enable sources so that we can see what are the documents that are actually supporting this. Now, the next step is what actually creates the vector index. We specify the vector index name, which matches what we specified in the profile. And we also have the profile name itself, the OpenAI GPT, which is saying, for creating the vector index, use the information that's stored here, in particular, the embedding model. We have the vector DB provider, which is Oracle. The location, this is my bucket and the particular folder. And then we have the object storage credential name, OCI cred. The second step, of course, is retrieval augmented generation, that whole workflow. And it looks something like this, where your natural language prompt comes in. You're using the narrate action, which we saw earlier. We have the autonomous database that's going to convert your prompt into a vector, use that vector to retrieve the relevant content, the most similar vectors and corresponding content from the vector store, which is an autonomous database, and then sending the augmented prompt to the LLM to return the result. And this is a fully automated pipeline. So let's move to our demonstration of how do we actually do this at the code level, because at part you would like to develop tools that take advantage of this. So let me just share it my other screen. All right, so we're going to switch to the notebook environment. And in this notebook environment, this is part of the Oracle Machine Learning notebooks, which is part of Autonomous Database. And this is built into Autonomous Database, so there's nothing you need to do to provision anything here. It's a fairly straightforward notebook interface. It will be running paragraphs this way, and there are various other features that are available for importing and exporting notebooks, versioning notebooks, and the like. Now, for more information, we have some links in here as well. But if you wanted to get started with Select AI yourself, there are just a couple of things that you need to do to enable that. The first is, as an administrator using the admin login, you would grant execute to the packages, the PL SQL packages that are supporting a Select AI. The key one is DBMS Cloud AI, which is directly for a Select AI. But there's DBMS Cloud as well as DBMS Cloud Pipeline that are used in this case. Having enabled those, you have configured network access to Oracle Cloud Services. We're using the access control list here to grant access there because it's a very secure environment, so explicit grants need to be made. Once you have that, there also are credentials for accessing the OCI GenAI services. And this is just a template to give you an idea of the types of things that you would specify to have access to those services. Now, I cited many other AI providers, and you can have credentials created to access any of those as well. And there are specific details in the documentation for your ability to access those. The next thing is to create an AI profile for retrieval augmented generation. And as I showed before, this is the one we're going to use to support the OCI GenAI RAG AI camp. We have the name of that. First deleting it here, but then we're going to create it. We have OCI as the provider, our OCI cred for the credential. We're using the Meta Llama 4 model. The embedding is the Cohere Embed English v3. And then the vector index is my vector index AI camp. Enable source offsets. Yes, we want to see what those are. And we also have the conversations. We want to enable conversations for this. And of course, we can give a description to this as well. So next, we're going to create our vector index. This is part 2 of that 2-step process I mentioned earlier. So we created the AI profile. Now we're going to create the vector index. And we're using a corpus of documents, a repository in object storage that contains text from the Oracle Machine Learning and Select AI blogs that I showed over here a moment ago. We can view the content that we have in object storage. Here's all of the documents. We see their object name, the text file, their size, and some other details about them. Now we can drop the previously created vector index, and then we're going to recreate it. So we'll just give this a second to process that. And in recreating this, a few details here. We have the profile, of course, the name that we're giving it. Oracle is the provider. This is the location where the documents are stored. And if we were in our OCI interface, we would see that these are the objects that we've actually stored in Oracle Cloud Storage. These are all of the documents that we're referencing there. We have the cloud storage credential because we need secure access to that content. And there are some other parameters that we can specify, like the vector distance metric, the chunk overlap, chunk size, a refresh rate, and the match limit as well. So let's just kick this off. And notice that, with the refresh rate, this is saying that how frequently would we like the system, the database, to check our folder to see if new content has been added so it can be automatically updated in our vector index. And so that's something that's very convenient to do. And there's chunk size and chunk overlap. You may be familiar with this. Basically, chunk size is how big, how many text characters do we want to have in each chunk. And the overlap gives some overlap between the various chunks so that you don't, say, break text in the middle of a word and have half a word in each chunk. So it gives you greater context from that. Now let's verify that we're running our pipeline. Okay, it looks like we have that going. Next, we're going to create a view that will allow us to look at the progress of our processing of the vector index. So we see a number of these are completed already. Actually, it seems like the entire thing is completed while we're speaking. So this is now ready to be used. We can look at the details of our vector index. So in this case, we're going to look at some of the attributes. You see the refresh rate here is 60, so 60 minutes. Once an hour, it's going to be checking the location to see if we should include any more documents into our vector index. We have the provider as Oracle, the vector distance metric, and the other elements that we've talked about earlier. One that I didn't mention was the match limit. And the match limit is basically saying when I'm doing a retrieval augmented generation search, how many results do I want to have included in that final result? And so this is limiting how many text chunks will be provided to the LLM. Now we can view the cloud pipeline history itself and see this has succeeded. So this is the one that we were just working with. And we can get the table name for the vector index because, well, let's see what the vector index actually contains. We can actually look at that. So to view the content, we'll simply pull out some of the details from my vector index AI camp $vectab. We're only going to get the first 3 rows of this. But you see, this is the beginning of the content, the chunk that's there. We have the attributes, and I'm just showing the beginning and the end part of the attributes. Here's the file itself, and then the offsets. And of course, the vector. This is the vector representation that we have for each of those chunks in our vector store. The next item is to query data using Select AI RAG. Now, the capability we're going to use first is the SQL command prompt. So we set our profile in a stateful connection to our database, which we have here with the Oracle Machine Learning Notebooks. And by setting this, we're saying, okay, we want to use the this particular AI profile in all of the subsequent invocations. First one we're going to do is just a generic chat where we're asking, what are some of the benefits of RAG using Select AI? And what we get back from this, if we're just using chat, we're relying on the general knowledge of the LLM. You're just getting a general response. I mean, this could really apply almost to anything, but it's telling us understanding RAG, understanding Select AI, some of the benefits of RAG using Select AI, but this is overall generic information that the LLM may already know. If I want to do this specific to the documents that we have in our blogs, we can say, let's narrate what are some of the benefits of RAG using Select AI. And in this case, it's coming back with Select AI uses retrieval augmented generation. It offers several benefits, and it identifies some of those. And it points us to the specific documents and the offsets in those documents where the chunks that supported this result actually came from. Now, the next part is, what if I wanted to see the actual chunks? Instead of using narrate, we can use run SQL and issue that against the same prompt. And this is going directly to the vector index to retrieve the particular chunks, the data, as you see here. We see the source, what is the text document that it came from, the URL that corresponds to that, and then a similarity score and the start and end offsets. So you also have access to all of this information as well, not just the summarized result from the LLM. Now let's try another one using chat. What should I do to improve results from natural language to SQL generation? And this is coming back with a number of suggestions for this. You want high quality training data, model selection and fine tuning. These are all things that generally you would get from an LLM. But if I wanted something that was more specific, maybe I will use narrate and some of the content from the blogs that we have. And this is a very short response from that, but it's also pointing us to the blogs that will highlight more information on that and what you can do. You'll notice that it's going to introducing Select AI natural language to SQL generation on autonomous database, and even more importantly, 6 simple tips for better text to SQL generation. So you have access to that. We'd like to see the particular chunks that are there. We can do that with run SQL against the same prompt. Now, we've been doing this interactively from the SQL command line. However, you may want to incorporate this into code using PL SQL and invoke this using the function DBMS Cloud AI generate. And what this allows you to do is to take advantage of Select AI in Apex applications or any application that is stateless, where you need to provide the AI profile in each invocation because it's not keeping track of that context, if you will. So with generate, we specify the prompt, we specify the profile name, and the action. So we have chat happening first here. This is just going out to the LLM to produce that, and we're asking, which AI providers does Select AI support? Now, in this case, it'll come back with a response that doesn't really fit for us. It's giving us a few of these, but this isn't quite right because it's just relying on the general knowledge of the LLM. But if we can use this narrate action here and go against our private documents, we're actually going to get a much more accurate response, specific to what was highlighted in the blogs. Just give that a second to respond. It's taking its time thinking, but all right, we got that. And here it's giving the much more accurate and complete list. So we support a range of AI providers, everything from OCI GenAI service down to Amazon Bedrock and the OpenAI compatible providers. And we see that there are two sources that are highlighted. One, announcing additional AI providers, which of course we would list what the complete set is, and then a supercharged SQL unleashing AI queries with autonomous database. Both of those highlight the AI providers that we have available. Now, if we use run SQL with the same prompt, this will give us the individual chunks that are supporting that result. And this is in JSON format. So because we're producing the result via generate, we're returning in a single string, and that single string in JSON format can be easily processed by applications. Now, the next thing we'd like to highlight, because I mentioned this in the slides, is that we can use an in-database transformer. How do we do that? Well, there are a number of ways that you can take advantage of this. When you're specifying it in your AI profile, you're essentially specifying in the embedding model the name of the model with a prefix, database : and that tells Select AI to use the in-database transformer. But how do we get a transformer into the database? Well, we have a couple of models, a few models that are already converted from their normal representation into ONNX format, and so you can readily use those. However, if you want models that we haven't already converted, then you can use the Oracle Machine Learning for Python interface to access Hugging Face for specific models and have those converted into ONNX format so that you can import them. But in this case, we're using one that we've already converted at this location. We're talking about the multilingual E5 small model. So the sequence is essentially, let's drop the model from the database if it's already there. We then get the object from this location and place it in a directory. We have a data pump directory that we're using. And then we're going to use the dbms vector package to load the ONNX model. And in this case, we specify the directory where that content is, the file name itself, and the model name that we want to give it going forward. With that loaded, we can now see what are the set of models that we have loaded into the database. And you can see we have several here. There are various clip models. One of the things that we've introduced in general is this ability to work with image and text for AI vector search. With Select AI, we're not doing images yet, but that's coming later. We see the multilingual E5 small and the all mini LM are some of the other models that we can take advantage of. Now, having done that, we have the Select AI user. We're going to have that user create now this AI Camp 2 profile. And the main difference is the embedding model. That here we're specifying database : and the name of the model that we have up above in the database. And that's really all that we need to specify to enable this. We have a different vector index, and from there, we can drop our index and recreate that. And what this is going to do is use, instead of the transformer from our AI provider, this will do that directly in the database using the in-database ONNX runtime. All right, so that's kicked off. Let's see if our pipeline is created. Yes, pipeline 111, that looks good. We have our view that will allow us to note the progress. So this is completed. This is still running. And you see many of these others are pending. So we'll just give that a few more seconds to complete. A few of these are still running and pending. All right, I'd say that looks pretty good. So from here, we'll do what we did before, setting our new AI profile, which is using the in-database transformer. And we can use the LLM to answer something like, what does it mean to supercharge your SQL queries using Select AI? And this is just using the chat interface. So we're not going against the database with RAG. This will take a few seconds to complete its processing. But basically, we'll expect that it comes back with some generic information that might use the right words, but essentially it hallucinated a response to what we really wanted to know about. I'll just let that continue processing. So supercharging your SQL queries, it talks about a few things: query optimization, predictive analytics, and query generation. Basically, it's not quite what we have in mind for our answer. In contrast, though, if we use narrate, this is going to go against our database, and in particular our vector index, and it's going to tell us exactly what we expect to get from that, as well as the documents that we can look for more information. Supercharge SQL unleashing AI queries with Oracle Autonomous Database Select AI. A very interesting concept of how you can compose SQL queries with the generate functionality to operate your LLM over entire tables worth of data. So I highly recommend you check that out. If we want to get back the specific content, well, of course, we can do that with run SQL again. So this is the content that was used to produce that result. And we can go further with using generate as well. So because the blogs contain both Oracle Machine Learning and Select AI functionality, we can ask what types of monitoring or what type of monitoring is enabled in Oracle Machine Learning. And this will draw on some of the blogs that we have there to highlight that it's both data monitoring and model monitoring that come back for that. And that's built into the user interface that you see here. So we'll just give that another second to complete. And indeed, we have the two types, model monitoring and data monitoring. And as we'd expect, the sources are highly relevant to that. If we want to see the individual documents that are relevant, we can invoke this again, and we're going against the vector store to pull out the specific chunks of data that are present. And that's the end of our script and demonstration. So let me just head back to wrap up with our slide content. So for more information on Select AI, we've been going through a number of the blogs. I have the more recent ones here that you might find useful or interesting. Again, it's the general access is blogs.oracle.com/machine learning, and that will give you links to all of this. The documentation, of course, for Select AI in general. Try on Oracle Live Labs. We have several live labs that are available that are dedicated to Select AI. A video that help you go get started with Select AI, another view of that, and simplify developing RAG applications. So in terms of resources, if you would like to try Autonomous Database for free, you can use this QR code or the bit.ly link at the bottom for one of the specific live labs where you can try this out, develop apps using GenAI, Autonomous Database, and React, another free workshop in addition to the one I mentioned on the previous slide. And we have the bit.ly link for that as well. And of course, we invite you to join us at Oracle AI World, which is happening October 13th through the 16th. And you can register now at the QR code or the bit.ly link that's shown there. So with that, I thank you very much for your attention. And if there are any remaining questions, I'm happy to address those. I know that I'd like to give a shout out to Laura Zhao, who's been on helping to address questions as well. So thank you very much, Laura, for your support on that. Bill, back to you.
All right, great. Thanks, Mark, for the great presentations, and thank you all for all of the questions. Yeah, we have a few more questions. If you have questions, feel free to type in the chat. And if you prefer to ask questions, you also can raise your hand. I can unmute you, so we can have open discussions.
Well, I see one question here of, how user-friendly is it for someone who isn't familiar with tech or developers? And I think that's one of the things to keep in mind, is that what Select AI is giving through the DBMS Cloud AI package is the ability to work with your LLM as a developer, and to make it very easy for end users, application users, to benefit from this technology, but doing it through a database-enabled application. So it's to simplify the work of the developer to make this a very user-friendly interface for end users, and how they can couple that in. That's one of the motivations that we had for showing the Ask Oracle chatbot, because that's giving you an idea of how simple it can be to have a no-code interface that allows you to have that chatbot-like experience for that. Let's see, how resource intensive is deleting entries from the vector database, especially in cases of millions of mappings? Well, there are certainly optimizations that are built into the database to do this very efficiently, both for creating the vectors and managing the vectors afterwards. As new content is added, this can be brought into your vector index to allow you to update that, and then to update the vector index for efficient access. So depending on the number of vectors that you're working with, of course, your mileage will vary based on what type of resources you have available for your database. If you're operating in a small environment, you'll have one experience. If you have a much larger, say, Exadata type environment, you would have a different one again. So I think it really depends on, do some benchmarking, see what your particular experience is based on the volume of documents that you have in mind. All right, are there any other questions, Bill, coming over?
Let me check. I don't see any more. Oh, here we have just one coming up.
See, we have RAG and not CAG. Well, there are a couple of different ways of dealing with that. We support retrieval augmented generation. There are a variety of other ways of interacting for augmented generation. And at present, we're focusing only on the retrieval augmented generation, working with the vector search and the AI vector search in the database itself. Do you see RAG becoming a standard database feature across industries in the next 3 to 5 years, similar to how indexing search became standard? Well, I don't know. It's hard to say standard. I mean, it is a database feature at this point that is extremely valuable for retrieving content based on semantics. And there are a variety of ways in which you can enhance the results that you're getting back from vector search, right? There are different ways of doing chunking. So what we've illustrated here is this notion of doing chunking based on a chunk size, the number of characters, and some overlap with that. However, there are other capabilities of doing a graph type of relationship between content in documents, and also for chunking based on paragraphs, or based on the headings that you have in specific documents. And so these are all different approaches that can be leveraged to further enhance the retrieval that you're getting, the retrieval accuracy you're getting from your vector indexes. As far as it becoming standard, I think it's really getting people to understand how to use this technology. And by making it so easy through, say, Select AI to generate the index and to work with it from retrieval augmented generation, I think that more people are going to start adopting this as an enhanced search approach instead of trying to do specific text matches, which we know is not good from a semantic perspective. We need something that's more general.
Thank you for all the questions. Anybody have the last minute questions? Again, if you prefer to speak to ask questions, you can raise your hand. I can unmute.
I do see one question here. Does this work with on-premises database? So that's an excellent question. Today, what we've done is we've introduced with the Oracle Database 23.7 the ability to use natural language to SQL generation. So you can take advantage of Select AI for natural language to SQL generation. We have not enabled RAG or synthetic data generation for Oracle Database yet. That's something that will be coming in the future. And in terms of database versions, certainly anything that requires RAG must be on 23AI because 23AI is supporting RAG currently. Select AI natural language to SQL generation is available with a 19C autonomous database. So you do have the ability to take advantage of the NL to SQL capability with 19C autonomous database. A question, how do you add additional information from, say, ontologies when you create vector search entries? Well, at this point, the only information that we're leveraging is are the documents that you specified in, say, whatever cloud storage that's being referenced or other document repositories that we support. And so we're doing the chunking of that and generating the vectors from that. There's no supplemental information yet that we've incorporated to allow users to supplement what is being added to the vector index other than the documents themselves and how they're being chunked. Do we have to run it only in OCI? Any place that certainly 23AI with autonomous database is available, you can take advantage of that. So you have more flexibility than just OCI. When we talk about leveraging the LLMs from a private LLM, I mentioned that. Currently, we're supporting that with OCI VMs. However, it is part of the roadmap to extend that to other private LLMs as well. So you will have even more flexibility going forward. Okay, I think that closes it for questions right now, Bill.
All right, great. Yes, thank you so much for all of the great questions. And well, thank you everyone for joining us today. And I think we just have one more coming up. Let's take this one as the last questions, if you want.
Okay. Sorry, can you? I'm not seeing that quite yet. Can you read it out?
I think it popped up.
Popped up, but I don't see it in the chat.
Oh, it's in the Q&A. How is data security and compliance level are implemented?
Well, data security is a whole other topic we could spend a lot of time on. I mean, certainly the data that the user who's logged into the database to use Select AI, everything is geared towards the, say, table data that they have access to. And the AI profile is specific to their access as well. So you would grant any tables that you want to have used for natural language to SQL generation, you would use the regular database security mechanisms to support that. And of course, the vector index is also within that user's schema, so it's subject to the security protocols there as well. There are a number of other ways that you can and deal with security, virtual private database, having the private LLM. Will be launching a blog shortly that will give you more details how to do that. There will be some other blogs coming out that talk about security in more detail. So I think I'll defer to those because, as I said, this could be a topic unto itself.
All right, I think we are on time. Again, thank you so much, Mark and Ivana and Laurel, for all of your support. Let's give them a round of applause and a thumbs up. I can.
All right. Thank you all very much for attending.
Yeah, great. Before we concluded, there are a few follow-up tasks, and I sent the event survey, the link to the chat. Please take 1 minute to fill out the survey. Give us the feedback. Your input is super valuable for us to planning for the future events. Anything we can do, improve topics you want to learn. We will make sure to get into the future events. The link is in the chat.